Welcome students. Now we will start electric potential. Now the question is, what is electric potential? We know gravitational potential energy. Suppose I raise this pen from the ground. I am doing work against the gravity. So whatever I have done this work, it is stored in that pen. If I release, it falls. So how it got that energy? Whatever the external force was done to bring that pen that was stored inside the pen as gravitational potential energy. Okay, let us start. Come to the point directly. Let us take, this is my source charge. Let it is positive in nature. If it is positive in nature, definitely this is my electric field, isn't it? I want to know potential at the point P, which is at a distance r from the source. Now listen it carefully. How can I do it? Now electric force is acting these directions away from the source. So who is this Q? What I am telling, this is source. I am to place a test charge here. Who is this Q naught? This is nothing but test charge. Now I want to move it from infinite to this point, to the point P. Let this point is anything I can write. Okay. So what is the amount of energy I want to bring? I want to bring that test charge from infinite to this point against the electric field. This is the direction magnetic field. I want to move this against the electric field. That is known as potential energy. Suppose this point is B. This point is A. Now my question is, sir, what is the potential energy at the point A? What is the potential energy at the point B? Let us write it. Suppose this is my WA is my potential energy at point A. WB is potential energy at point B. If test charge is positive, that means electric force is this direction, electric field is this direction. I am doing some work against the electric field. So what are you thinking? Is it easy to bring to the point A or to the point B? Obviously, for a magnet, if you try to remind, nearer to the magnet, more repulsion you will get, more repulsive force. That means obviously at the point A, work done at the point A is more or less. It will be less, of course. At the point B is more. Sir, if it would be minus, test is plus, then it will be reverse. Minus case, opposite case, it will be easy. In minus case, it will be difficult to drag it away. In both plus case, it is difficult to push it towards. That's why whatever the case for positive test charge, minus case it will be reverse. Now the question is, so what is potential? So potential at the point A. How can I write potential at the point A? Let us write down. Definitions also similarly. Potential at a point is defined as the amount of work done. Let me write potential definition. Potential at a point is defined as amount of work done per unit test charge. In this case, positive test charge. To bring a charged particle from infinite to that point. So what is the definition? You have to mark here per unit charge. If I remove this, it will become potential energy. It will become potential energy. If I add this, it will become potential. Now, that means potential at that point A will be VA by Q. So potential at the point B will be equal to WA, so by Q, in this case WB by Q, work done per unit test charge. Now the question is, what will be its unit? Obviously it is joule per coulomb, or combined it is known as volt. So what is 1 volt? I can write 1 joule per 1 coulomb. So can you define 1 volt? Look it here. Just I will, same thing, I will change it in terms of, so potential at a point is said to be 1 volt. I have to write here. If 1 joule of work is done to move 1 coulomb of charge from infinite to that point. Very simple. Just I will place, in place of work done it is 1 joule of work, in place of charge I will place 1 coulomb. Now my question is, so what is potential difference? Okay, I got potential, I got what is potential definition, I got what is 1 volt. Now what is potential difference? In this case del V. What are you thinking, del V, who is bigger? I told obviously this is bigger, means WB by Q means obviously potential at point B is greater than potential at point A. You can refer books also, no problem for definitions. Now what is potential difference? In this case, that is VB minus VA, in one word is written as A to B. A to B means I want to move from A to B. I want to move from A to B. So what will be its definitions? Very simple definition. Look it here carefully. Amount of work done to move, amount of work done per unit test charge to bring a charged particle from lower potential to higher potential, or from a point to another point, is known as potential difference, that is VAQ. In this case also similarly, what is 1 volt potential difference? 1 volt potential difference is, now we will go for, so we got what is potential, we got what is potential difference, we got what is 1 volt potential. Similarly, they can ask you what is 1 volt potential difference. Now what is potential energy? These are the basic concepts required. Suppose I want to know now, some questions can be asked. Let us go for the questions. If 10 joule work is done to move 2 coulomb charge, of course not 2 coulomb is not possible, 2 microcoulomb charge, suppose from infinite to a point which is 2 centimeter away from, let 2 coulomb charge, or let to move a charge particle. Okay, to move 2 microcoulomb. Let us keep it. How to solve it? My question is now, what is potential? Now potential, what is the potential energy? 10 joule work. So what is potential? Work done by charge. That means 10 joule by 2 coulomb. So it become what? 5 joule per coulomb is 5 volt. So similarly, simple questions will be asked. We will see in the next page, how can I find potential at a point? My question is now, how can I find potential due to a point charge? Then we will go for multi-charge. Very simple thing. Okay, let us consider, here is my source. Let this is source plus Q is there. And I want to know, so obviously by default blindly I will tell this is my electric field. I have to move from infinite. Like at the point P, I want to know what is the potential. What is Vp? How can I write? Which is at a distance, let it is at a distance r. Before that, let us consider I am doing at the point A, who is at a distance x. Let us place a test charge at the point A first. I want to move to the point B, so I am to move A to B. And the displacement, this is the distance is dx, so displacement is from our right to left. So what we have to do? We have to apply some external force. And let F is the external force. And here, what is the displacement? Dx is the displacement. So I have to start, and here displacement is nothing but dx. So what is the work done, external work done to move this charge particle from A to B? How can I write? So what is the elementary work done to move from A to B? That elementary work done is obviously F dot x. But here F is due to external force. Okay, so external force, this is external force direction, because I want to push it, that is external force, this is the direction. But what is the electric force? This is electric force directions, left to right, external force, right to left. So in this case, it will become what? F external dx cos 0, because they are in same direction, it will be 1. I want to know what is the electric work done. In that case, electric force dot dx. But electric force is towards left to right. Dx is displacement is towards, this is the displacement direction, right to left. That means angle between them is 180 degree. This is my electric force. Check it here carefully. This is my electric force and this is my displacement. So angle between them is 180 degree. So that is F electric dx cos 180. Cos 180 is minus 1. So I will write it minus F dx. Let us mark it F and electric Fe dx. But what is force? As we know, electric force acting on the test charge Q naught, let the charge here Q naught, then I will write F is QE. That means minus QE dx. This is my elementary work done due to electric force. I want to know, so from infinite to the point P, what is the work done? So from infinite to the point P, work done will be net work done W. This is nothing but dW integrations. That means minus Q is, come on, I can take it outside. Okay, let us write down minus QE dx. Integration will be what? Infinite to B. That means infinite to P, because I want to know potential at point P. Infinite to P means infinite distance to R distance. So infinite to R. Now, what is electric force formula? Let us write down. Electric force formula is kq by r square. That means 1 by 4 pi epsilon naught q by, at the point, this E I want to know at the point A. At the point A, electric field is x square. So let us put that value here. So what is the work done? So this work done now becomes minus q limit infinite to r distance. This is 1 by 4 pi epsilon naught into little bit change. What are the changes? What is that? F is QE. Here I am writing F is QE. Q is the test charge. This is Q naught. Obviously this is Q naught. Now E is KQ by R square. KQ is Q for source. So I will write here K capital Q. Otherwise we will be in trouble. So this test charge is moving outside. So here KQ by R square. In this case distance is X square. These are constant, will move outside. So minus Q naught Q by 4 pi epsilon naught X square. Sorry, X square is not constant. Limit infinite to R 1 by X square. How can I forget dx with respect to X? Now 1 by X square limit is X to the power minus 2. So n plus 1 by n plus 1. So I will get it here minus Q naught by 4 pi epsilon naught. I will get 1 by X square limit is minus 1 by X minus infinite to R. Now this is minus minus will be cancelled. So this will be Q naught Q by 4 pi epsilon naught. I will write here 1 by R upper limit minus lower limit. And as we know 1 by infinite is 0. So 1 by R. So I got my work done is nothing but equal to Q naught Q by 4 pi epsilon naught R. If I want to know work done per unit test charge, this is nothing but potential at the point P is nothing but equal to Q by 4 pi epsilon naught R, or what I told, this is KQ by R. So this is my potential at a point KQ by R. Electric field intensity case KQ by R square. And what we got for potential, this is nothing but potential energy. This is nothing but equal to KQQ by R. Like force KQQ by R square. In this case KQQ by R. Remind it, since work done is scalar, so I will write this is a scalar quantity. Sorry. Now I want to know potential due to dipole. And from here another formula also we can derive it. Line integral of electric field and potential relations. Some other time I will tell. Let us go for potential due to dipole. Easy one. Let us consider this is the dipole. I want to write here for axial axis case. Let this is point A, this is point B. Potential easy thing is that this is my dipole length. Let this is origin O. Length is L. This is axial axis. Let this is the observation point P, which is at a distance R. So AP will be equal to R plus L, and BP will be equal to R minus L. Now I want to know potential at the point P, means potential at P due to A, potential at P due to B. General addition. Why general addition? Because it is scalar. Now what is potential? Let here the charge is plus Q, let here charge is minus Q. So what is the formula? KQ by R. K due to H plus Q by R means AP. AP, what can I write AP distance? R plus L. Plus KQ by due to B. But it is minus Q. Because here charge is minus. Remind, in force and electric field intensity case, I told not to put the sign because we are writing directions. Here, since it is scalar, whatever the charge, we have to put it there. So potential will be positive if charge is positive. Potential will be negative if charge is negative. So KQ by R. What is that R? BP. What is BP? R minus L. So KQ is common. I am getting here 1 by R plus L minus 1 by R minus L. Now if I will solve it, I will get R minus L minus R plus L. So RR will be cancelled by R plus L into R minus L, and here R will be cancelled, and whatever I am getting, this is minus. Minus means if you will take, look it here, if you will take minus here, obviously potential for this will be smaller, potential for this for plus will be bigger. Book you will get it is 2LQ. Why it is minus? Because I took minus charge nearer to the source. If I would take minus here plus here, the net would be plus. So I am getting here K to QL, obviously minus to QL by R square minus L square. So this is, we know 2LQ is nothing but electric dipole moment. So minus KP by R square minus L square. Again, let me tell you why minus occur. Because I took minus charge nearer to the source, nearer to the test. That's why this potential is bigger than this. That means negative potential is bigger than positive potential. That's why minus. If I would take plus here minus here, that means positive potential will be bigger than negative potential. Then I would get the lesser things. And as you know, for greater ideal case, R is very very large than L. R square minus L square will become tends to R square. So in this case you will get potential at P will be equal to Kp by R square. Similarly, lots of problems also you can solve. Sometimes they will ask, what will the potential at Q? That means I am asking, potential at Q will be what? Obviously it will be 0. Let us go for potential at O. Same distance, opposite charge, they will cancel to each other. For example, I am writing potential at O. That is potential at A plus potential at B. Potential at P at O due to A, at O due to B. So potential at O due to A is plus Q by L plus due to B is minus Q by L. All same, plus minus, that's why 0. So at center potential is 0. Now we will go for the next part, potential due to dipole if it is equatorial case. So I want to know potential due to dipole case 2. It is equatorial case or equatorial axis. Let us draw a very simple thing. Let this is the dipole, point A, point B. Let us take this plus Q, let us take this minus Q. This is the center, as we know. This is our equatorial axis. This is the point P. Let this distance is R. We know this distance is L. So what is potential at A due to P? Potential at P due to A, potential at P due to B. What is this distance? Let it is X, which will be R square plus L square square root. So this will be also R square plus L square square root. So let us apply. What is potential at P? At P due to A, at P due to B. Due to A, that is K Q by r. What is r? The distance AP, r square plus L square square root plus K, here charge is minus Q by r is BP, r square plus L square square root equal, and since minus sign is there, is 0. Lx is potential is 0. That means this line I can tell it is equal potential, that is 0. Potential difference is 0. So this potential difference 0, so here work done will be 0. How work done is 0, I will tell you. So this is equipotential line. This line is also known as equipotential line. Why it is equipotential line? Because potential difference at any point is 0. Okay, that's it. So what we learned today, already for the electric dipole we earlier derived this, that is P cos theta by 4 pi epsilon naught r square, or that is Kp by r square into cos theta. And this is the for case 1, case 2. For axial case, let us check it. Are we getting? So due to axial case, Kp by r square, yes, we got Kp by r square. Due to equatorial case, we got it is 0. Obviously we are getting 0. Now electric potential, this is the concept we use today. Potential due to point charge, this is nothing but Kp by r, or 1 by 4 pi epsilon naught by r. This is for the axial case derivation and equatorial case derivation. I hope you enjoyed the class. Thank you.